We're now in the main plant room. Basically this was the existing plant room, and what we've done is we've altered the pipe work to form what's called a low loss header, which is this big long pipe here, and basically we have all the returns for the building on one end and all the flows for the building come back in on the other end and mix in the middle. So we have, I'll go through the valves. We have the first valve on it is the hot water return. These are all labelled up on the chart, numbered and labelled on the charts. The second one is the kitchen return. The next one along is block D return, and then we go to block A return and block B return. It's the same principle on the flow. It goes kitchen, block A, block B, block D. Pumps that we've installed. This is the main pumps which feed the new block D and also the underfloor heating systems in the hub. We then go back through, we have the two pumps at the top serve the kitchens, the two pumps below it serve block B. We then have two pumps here which do the hot water. This is the hot water to the two new cylinders. We then
installation here at Beal High School. We're in the plant room at the moment. This is the main control panel. There's a number of these dotted around the school. This is like I say, the main one. Within this compartment there's some low voltage BMS controllers. This is the BMS controller interface. It's more intended for use by engineers, although users can enter a basic mode and view various statuses and set points of the system. With regard to the fascia of the control panel, up the top here we've got two white lights. It's fairly simple. If they ever go out, there's a fairly serious problem, and it's best to call the number, call your maintenance providers, or by all means call us. The number's on the front of the door, and the job reference is on here as well. So those white lights indicate that the control circuit is on, live and healthy. They will only go out in a serious failure, power cuts, or if a fire alarm has gone off. There's a knock-off button by the door which will shut all of this down. There's some fire detection equipment in here above the boilers if flames
So this is the
detected.
main navigation menu system. You've got your air handling plant in the roof plant rooms at the top. Interface to the Mitsubishi system showing all the fan coil units. We've got another panel down in the tank room with some ancillary monitoring, and then we've got the traffic light alarm system showing reds and greens for healthy and fault. Same kind of thing for the Mitsubishi system, and then some electrical metering information. So I'll go through from the top. So north plant room, we've got air handling unit number 1 and associated toilet extract and domestic hot water. So if we start with the air handling unit.
Which is north?
That way.
So it's to our right.
Yeah.
Okay.
So the air handling units are all fairly similar. You got the supply air coming in through a damper. So if this air handling unit has ever been off, when it's switching back on, the first thing that has to happen is this damper has to open, and only when it is open can the fans start to run. So there's that interlock for the supply and the extract. So the air comes in, we monitor the inlet temperature.
Hi, I'm John Bailey. I'm an engineer from Progressive Networks. We are at Hatfield University. Here at Hatfield University we have installed network cabling, Cat6 XL network cabling. Cat6 is the category of cable, XL is the branding. We've installed approximately over 240 cables here to Prince Edward. Prince Edward is the main reception building, as well as it has classrooms, theatre rooms, etc. This is your server cabinet, essentially. This is what houses the patch panel end, and these are patch panels of the structured cabling. Now, as you can see, they're actually labelled room 110, which it says here, and we are actually in room 110. So room 110 is then corresponding to the lower ground, which are the lower ground cabling, and then the actual outlet number, which we'll show you later, which is 001, running concurrently up to 240. Also, we've installed a fibre optic backbone system. These fibre optics are 12 core, and this is going from room B110 to room 9-125. which is a intake room within the actual main university compound.
We're in the central core plant room on the 3rd floor. This is the air handling unit number 2 that provides supply and extract air to the central core of the building. The top fan is the extract fan, and the lower fan is the supply air fan. The extract air actually isn't ducted. There's louvers at low level, just the other side of these, the ductwork here. The extract air is then drawn through the atrium from the classrooms and everything via crosstalk attenuators and the linear grills. Here we have the inverter speed controller for the air handling unit, and also here is the gauge for the filters. The red indication here is when the filter is dirty and needs changing. So at the moment that's currently showing that the filter is in need of changing, which we will be doing shortly.
Once testing has been carried out, you must open this top valve. It's imperative this valve is opened. Failure to do so will render the system unoperational. And relock it. This system is now back to its operational state. So we've recorded the date, we've recorded the before pressure, we've recorded the after pressure, we've recorded the time taken for the gong to ring. The gong worked satisfactorily, stop valve is secured open, all other water supply valves are open, water storage tank full, and physically open the hatch and check the water level is full. We have just done the weekly test, so therefore water is seeping back into the tank. This will stop once water level has reached its full mark.
Okay, this is the DVR. It's a Hikvision DVR with 1 terabyte of hard drive. You've got 22 cameras. You're gonna have 23 once the cable's the last one have gone in. They're IP cameras, so the quality is pretty impressive. So actually, if you want to get the functions of it, are pretty easy. You've got a mouse here, so you can sort of right click. If you want to do an individual camera, you can trawl through here, just click on that and that camera comes to view. If you want to go to multi-screen, so you can 2x2 multi-screen, you can whatever you basically want to see throughout the day. All the cameras have been set up. We've done them at 6 frames per second. They're all a motion record, so they're all there all the time. As soon as you can see on this camera here, as soon as that guy walked in front of there, you get the alarm come up and it's starting recording, and that's how they're set up all the time.
Well, we're in Block B on the 2nd floor. This is typical riser, and we have the basket for all the data. This is all the data cabling, and we have a separate basket for power and BMS cables, and we have the disk board, and behind this door is the emergency light test switch. The emergency light test switch here controls all the lighting on this floor and reverts to each circuit. A couple of spares, and we also have a switch here which does the light in this cupboard. We have a lighting section on the disk board for the whole floor and a power section for the whole floor. Each breaker has its own reference. Again, this is in the O&M manuals available for the maintenance staff. The circuit numbers relate to the circuit numbers on the switches and the socket outlets. These typical ones here on the power are RCD protected, and they have a trip switch, which should be. This is Block A, main switch room, in the ground floor, just under the stairs behind reception. This is the main panel that feeds the other buildings, B, C, D, Students' Union, which is all labelled up, temporary kitchen, and all the labels and the metering shows quite clearly what they are feeding. The disboards, local disboards in this block as well. The main switch is here for the whole panel, and that'll turn off all the blocks. This is fed from the GRP room, which we've just seen, over in the behind Walworth House. All the local boards come off this for this area. We have a typical multi-function meter for all the services that are off this panel. Each area has its own meter, whether it's Block A, kitchen or annex. And you scroll through, just going through the keys, it tells you quite clearly the kilowatt hours. Scroll down, it tells you the current run and what amperage is per phase, the kVA for each phase.
So what we're going to do is, with the system in normal mode, which unfortunately it isn't at the moment, I'm going to put a controls activate key in the panel to enable the push buttons and turn that to the right. And for a weekly test you utilise this shape key, insert to the middle of the brake glass at the bottom until it clicks, and then pull the key out, generating a fire condition. And having got the fire condition to register, you then snap the brake glass shut again by squeezing it top and bottom. And then on the panel we can mute the internal buzzer, silence the alarms, and ultimately we can then press the reset button, which should take us back to a system normal, and remove the key. And that is basically how you go about a weekly test.
My name is Gary Foster, I'm from Evo Energy, and I've come to demonstrate the solar PV system. We're in the third floor plant room. So this is your inverter. This is where the DC power coming from the roof, which is here, is transformed to AC power and exported to your distribution board. So these are the DC isolators. There's one for each string. There is a string drawing just here which shows where all the strings on the roof are, and each one of these DC isolators will be labelled, and they show each isolated string. So if any strings need isolating, this is where it would happen. And then this is your generation meter. This measures all of the energy that has been created by the solar power, and this is where you will get your FIT reading from, which is needed every 3 months for your energy provider.
Okay, this is a toilet extract fan control panel. It's controlled by the BMS, it's on the roof, and it's got a DP switch across it checking airflow. It's got 2 run lights, one will run only at one time, and it's got a fan fault. So if there's a problem with one, it'll change over automatically to the other one and show that fan fault. That's showing that the panel's live and you've got power coming into the unit, and then you can change the fan speed by altering this thumb turn knob around. Don't use the time zone here because the BMS does the times on and off. This is just not really needed, but in there anyway. So that's the extract fan.